Good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and our lesson for today is all about joint variation. Let's try to recall first our previous lesson. In letter A, translate the following statement to mathematical equation. Use K for the constant of variation. In number 1, the amount of paint P needed to paint the walls of a room varies directly as the area A of the wall. This example or number 1 is an example of direct variation. If we will write this in mathematical equation, that is capital P is equal to KA. Next, let's try to answer number 2. The base B of a triangle varies inversely as its altitude h. Since this is inversely, meaning to say that example number 2 is inverse variation. If we will transform this to mathematical equation, that's B is equal to K all over h. Next, number 3. The mass m of an object varies inversely as the acceleration due to gravity. Again, number 3 is an example of inverse variation. So if we will write this in mathematical equation, that is m is equal to k all over g. Next, number 4. The weight W of an object is directly proportional to its mass m. Again, number 4 is an example of direct variation. So that is capital W is equal to Km. And number 5, the length L of a rectangular field varies inversely as its width W. That is L is equal to K all over W. Now let's move on with letter B. If y varies inversely as x, find the equation of variation if y is equal to 15 and x is equal to 3. First is we're going to find the correct equation. It states here that y varies directly as x means the equation is y is equal to kx. Next, to find the equation of variation, we're going to solve first for k or the constant of variation. And to solve for that, we substitute the value of y that is equal to 15 is equal to k multiplied to 3. Divide both sides by 3 to obtain the value of k. So this is now 15 divided by 3. Our k here is equal to 5. To find the equation of variation, we will just plug in from y is equal to kx, substitute the value of k. We now have y is equal to 5x. Okay? Next, this is now our equation of variation. What about in letter B, number 1. If y varies inversely as x, find the equation of variation. So first we look for the correct equation, and that is y is equal to k all over x. If we will translate, y varies inversely as x. Next is to find the equation of variation. We plug in these values. We have y is equal to 10. That's equal to k all over 4. Next is to get the constant of variation. If that is inverse, we simply multiply the two quantities. Meaning to say k is equal to x times y. The value of x is 4 and our y is 10. So 4 times 10, the constant of variation now is equal to 40. And the equation of variation, we substitute from our equation, y is equal to k all over x. And we know that the value of k here is 40. That is why the equation of variation here is 40 all over x. Relationship between one variable over another variable were given emphasis in our previous discussion. Relationship could be directly or inversely proportional, but sometimes one variable may vary directly or inversely with more than one variable. That is why we have joint variation. Joint variation occurs when a quantity varies jointly with the product of two or more quantities. Again, k is the constant of variation. Example, we have y equals kxj for some constant k. We read this as y varies jointly as x and z, or y is jointly proportional to x and z. For activity number 1, let's try to transform the following statement to mathematical equation. Use k for the constant of variation. Let's say number 1, y varies jointly as r and t. If we will write this in mathematical equation, that is s is equal to k r t. Next, number 2, V varies jointly as L, W, and H. That is now capital V is equal to K, L, W, H. Number 3, A varies jointly as B and the square of C. If we write this in mathematical equation, that is capital A is equal to K, B, C raised to the second power, since that is square of C. Number 4, the electrical voltage V varies jointly as the current I and the resistance R. That is capital V is equal to K, I, capital R. And number 5, the pressure P of a gas varies jointly as its density D and its absolute temperature T. That's capital P is equal to K, capital D, capital T. Okay, so that's how we transform equation to statement to mathematical equation. Let's try to solve problems involving joint variation. Example number 1. Find the equation of variation where A varies jointly as B and C and A equals 36 when B equals 3 and C is equal to 4. So step number 1, we have to find the correct equation. And we have here A varies jointly as B and C. If we will translate this to mathematical equation, that is A is equal to K, B, C. Next is we plug in the value of A, B, and C to solve for K. So our A is 36 is equal to K multiplied to our B, which is 3, times C, which is equal to 4. Next is we simplify. That's now 36 is equal to K multiplied to 3 times 4. That is 12. Next, we'll solve for K by dividing both sides of the equation by 12. So this is cancelled out. Then we have K is equal to 36 divided by 12. And when you divide 36 by 12, the value of K is equal to 3. So from our equation, we will now form the equation of variation by plugging in the value of our K. So the equation of variation now is A is equal to 3BC. Okay, let's proceed with example number 2. If z is jointly proportional to x and y, and z equals 6 when x equals 3 and y equals 4, find z when x equals 7 and y equals 4. So again, step number 1, we have to find the correct equation. So we have here z is jointly proportional to x and y. That is z is equal to k x, y. Next is we solve for k by plugging in these values. We have say is equal to 6 is equal to k multiplied to our x, which is 3, and y is equal to 4. So to solve for k, we multiply this part. That's 6 is equal to k. 3 times 4 is equal to 12. Then divide both sides of the equation by 12 to solve for k. So k is equal now to 6 all over 12. Lowest term of 6 all over 12 is 1/2. Then we substitute the value of k to find the equation of variation, or we have now the equation of variation by simply plugging in the value of k, which is equal to 1/2. So that's now z is equal to 1/2 x, y. So after this, we can now solve for the value of z when x is 7 and y is 4. So we substitute. To solve for z, we have 1/2 times the value of x now, which is 7, multiplied to y, which is equal to 4. So we now have z is equal to 7 times 4, 28 times 2. times 1, so that's 28 all over 2. Then 28 divided by 2, the answer is 14. So the value of say when x is 7 and y equals 4 is equal to 14. For our last example, the area A of a rectangle varies jointly as the length L and W width, and whose area is 72 square centimeter when length is 12 centimeter and width is equal to 2 centimeter. Find the area of the rectangle whose length is 15 centimeter and whose width is 3 centimeter. So again, first is we write the correct equation. That is the area A of a rectangle varies jointly as the length L and width W. If we translate this to mathematical equation, that is A is equal to K L W. Next is we solve for K given this value. Area is 72 is equal to K times our length is 12 times the width 2. So we simplify this part. We have 72 is equal to K times 2. 2 times 12, that is 24. Divide both sides of the equation by 24. So K now is equal to 72 all over 24. When you divide 72 all over 24, the answer is 3. So our K is equal to 3. Then we now have the equation of variation from A is equal to KLW. That's A is equal to 3LW. So we can now solve for the area given the following condition. That's A is equal to 3 times we have 15 multiplied to width, which is 3 centimeter. So we now have 3 times 15 times 3. The product is 135 square centimeter. Okay, so again, please don't forget to write the units. So our answer here, the area is 135 square centimeter. Okay, so that's all for now. Thank you and good day.